Hello students, good evening all. This is your KP sir. Today I am here to discuss UPPSC AE or AEE part 15. Till now we have completed 14 parts related to hydrology. So now today we are discussing about problems related to hydrograph and unit hydrograph. Before going to start the session, I would like to inform you one thing, that is myself Krishna Prakash. I am going to teach environmental engineering, hydrology and irrigation in Unacademy platform. So my code in Unacademy platform is KP Civil. Take your plus subscription using the code KP Civil. GATE and ESC full length. I am teaching environmental engineering 140 hours and hydrology 120 hours. This much depth of subject no faculty will teach you. So in Unacademy full length GATE and ESC course I am going to launch. Already it was started in 29th September. So as early as possible, enroll yourself for plus subscription in Unacademy. If you have any doubts, queries regarding your subscription, regarding plus course, regarding your career subject, anything, you ping me 898593312. I am ready to help you, ready to support you at any time. Okay. Now, today's discussion is numerical questions or whatever objectives related to unit hydrograph. The first one, recession limb of a hydrograph signifies. Recession limb of a hydrograph signifies. We know the graph of hydrograph. We have plotted the hydrograph. Clear? This is the graph now. We have plotted hydrograph. This is the graph. Where recession limb located? This point D to point E. It is a recession limb. Recession limb is a falling limb. Na? Recession limb of hydrograph located point D to E. Point D to E. So it represents, what it represents? A depletion. Storage is falling down. Accumulation of storage is shown by rising limb. Falling down of storage is represented by recession limb. So what is the answer? Recession limb is going to represent. Recession limb is going to represent depletion of storage. Very important theoretical question. Recession limb of hydrograph signifies depletion. When a 2-hour unit hydrograph is available, other unit hydrographs of the following duration may be easily predicted except. So 2-hour unit hydrograph is there. Based on 2-hour unit hydrograph, any time greater than d hour. What is d? D is equal to 2. D is equal to 2. So any time more than d hours. So what is d now? More than 2 hours. Is it not? More than d hours means more than 2 hours. So we can plot 4 hour, we can plot 5 hour, we can plot 8 hour. So possible, 4 is possible, 5 is possible, 8 is possible. All the 3 possible. What is not possible? Question is, following duration may be easily prepared except what you are unable to prepare? Except 1 hour. Unit hydrograph of 1 hour is not possible. You can plot any kind of unit hydrograph except 1 hour unit hydrograph. The word unit in the unit hydrograph denotes. Clearly in the definition in the last session I have written what is unit. Tell me my dear students, you know it? The word unit in the unit hydrograph denotes. Clearly we have written unit in the unit hydrograph is unit depth of effective rainfall. Unit depth of, I have written clearly ERF. ERF is nothing but effective rainfall, which is called runoff, which is considered as runoff. So, the unit depth of effective rainfall. Option A. The word unit in unit hydrograph. I have a question here. We are writing 2-hour unit hydrograph, 6-hour unit hydrograph, 8-hour unit hydrograph. What is this 2, 6, 8 represent? Or simply all are represented, we are representing D-hour unit hydrograph. D may be 2, D may be 6, D may be 8. What is D represents? What is the meaning of D? D represents, tell me, D-hour unit hydrograph, D represents duration of rainfall. Duration of rainfall. If your rainfall is 2 hours, you plot 2-hour unit hydrograph. If your rainfall is 4 hours, you plot 4-hour unit hydrograph. If your rainfall is 6 hours, you plot 6-hour unit hydrograph. So D is the term D. D represents duration of rainfall. We'll move on. Next question. The 4-hour unit hydrograph of a basin. So 4-hour, what is 4 here? 4 is D, duration of rainfall. The 4-hour unit hydrograph of a basin can be approximated as a triangle. Okay, I am plotting the triangle. Can be approximated as a triangle. I am plotting the triangle with a time base of triangle with a base period. This base period will consider as 48 hours. Base period will take it as 48 hours. P coordinate, this P coordinate. What is the P coordinate here? 200. P coordinate of 200 meter cube per second. Area of the basin would be, from the beginning I am saying the formula, half into time base into P coordinate, peak discharge. That is equal to, tell me, area of the basin we can take now, area of catchment. We'll consider it now. Area of the basin or area of catchment will take into, what is depth? What is effective rainfall depth? Unit. What is the meaning of unit here? Meaning of unit 1 centimeter. 1 centimeter we are taking 10 power minus 2. 1 centimeter will consider, how will consider? 10 power minus 2. So now I am writing half into time base 48 hours, discharge 200 meter cube per second. I am converting meter cube per second to meter cube per hour, multiplying with 60 and 60. Half into 48 hours time base into 200 into 60 into 60. What is required? Area required, area of catchment needed into 10 power minus 2. Easy enough? Just we are taking a formula, for triangle half BH, substituting into area into 10 power minus 2. You will get area of catchment. So what is the area? Solving. So what you will get? Solve for A. Solve for A. What you are getting area? Tell me. Area is equal to 1728 into 10 power 6 meter square. In the options, what is there? Kilometer square. So 1728 kilometer square. Directly we will take it now. 1728 kilometer square is the answer. 1728 kilometer square will consider the answer. Okay. The time of overland flow is affected by time of overland flow. What is overland flow? Overland flow we consider as surface runoff. the time of overland flow is affected by, surface runoff is affected by, tell me, slope of the basin but not its length, ground surface but not the slope, length of flow path but not the area, slope and length of the path. No. Surface runoff is depending upon slope of the basin but not its length. Depending upon the slope, basin slope, surface runoff. Just remember like that. Time, it is not about total surface runoff they are asking. They are asking about time of overland flow. Very important. We are thinking about surface runoff only. We are worrying how to consider surface runoff, how to think about overland flow. But the question is not a full overland flow. Question is time of overland flow. Time of overland flow depending upon slope of the basin but not on the length. Large runoff is produced by drainage basin of the shape of. Have we discussed it? In the previous session, theoretical session related to hydrograph. Have we discussed it or not? We discussed it clearly. Two types of shapes, fan shape, fun shape, which is providing 100% no doubt. Fan shape catchment is providing. Is there any doubt? 100% no doubt about it. Fan shaped catchment is providing huge runoff, large runoff. A 252 square kilometer catchment area. A 252 square kilometer catchment area. 252 into 10 power 6 kilometer square. Has a 6-hour unit hydrograph. Very important, remember. Has a 6-hour unit hydrograph, which is a triangle with a time base of TB. 35 hours. Is a triangle, clearly mentioned, triangle. So this is the unit hydrograph we are plotting here. 6-hour UH, QUH versus time. What is the shape mentioned? What is the shape? Triangular, na? Triangular. And the time base is 35 hours. Good. The peak discharge of DRH due to 5 centimeter effective rainfall in 6 hours from that catchment. In 6 hours from that catchment. So what is the first peak discharge of QUH? Then obtained peak discharge of QUH into effective rainfall. Into active rainfall. ERF is given. ERF is given 5 centimeter. 5 centimeter. Based on that we can estimate. Is it clear? First we use the formula, triangular formula, half into time base. What is time base? 35 hours into peak discharge, QPK, required in meter cube per second. Time is in hours. So we are multiplying with 60 into 60. Time is in hours. Na? 35 hours converted to second. 35 into 60 into 60 is equal to 252 into 10 power 6. Unit hydrograph clearly given 6-hour UH. 6-hour UH. So into 10 power minus 2 effective rainfall depth. We'll take that effective rainfall depth. We'll consider. So what is QPK you are getting? Solving this, you will get unit hydrograph peak discharge. Solving this, what you are getting? Unit hydrograph peak discharge. Clear? Half into 35 into peak discharge into 60 into 60 is equal to 252 into 10 power 6 area into 10 power minus 2. 10 power minus 2 is 1 centimeter effective rainfall. 1 centimeter effective rainfall is for unit hydrograph. That is for unit hydrograph. What you are getting? You are getting 40 meter cube per second. After calculation, how much you are getting? 40 meter cube per second you will get now. Peak discharge of unit hydrograph 40 meter cube per second you are getting. Now, do you need peak discharge of unit hydrograph? No. Effective rainfall is provided. Remember carefully. Effective rainfall is provided. How much? 5 centimeter. Effective rainfall is provided 5 centimeter. So that peak discharge of direct runoff hydrograph. Peak discharge of direct runoff hydrograph. How can you calculate? Peak discharge of direct runoff hydrograph is equal to peak discharge of unit hydrograph into effective rainfall depth. This is only formula. Peak discharge of unit hydrograph 40, effective rainfall depth 5. So what you will get? 200 meter cube per second. This is the answer. Here, peak discharge of unit hydrograph 40 into effective rainfall depth 5. So 40 into 5, 200. What is the answer? Option. Tell me what is the option? Option C, 200 meter cube per second. Clear? First we are deriving peak discharge of unit hydrograph, then multiplied with effective rainfall. Multiplied with effective rainfall, that gives peak discharge of direct runoff. Viewing watershed as a system. The assumption made in the unit hydrograph theory is. What is the answer? Tell me. We have written clearly unit hydrograph assumptions. Viewing watershed as a system. The assumption made in the unit hydrograph theory is non-linearity. No. Both linearity and time variance. Shall we go for it? Shall we go for it? Linearity and time invariance, clearly written. So answer is linearity and time invariance, important. Here in is absent, don't confuse, don't go for this. In is absent, both linearity and time invariance. Viewing watershed as a system, assumption made in unit hydrograph theory, both linearity as well as time invariance. The peak of a 4-hour flood hydrograph is 240 meter cube per second, FH. QFH, which is called a peak of 4-hour flood hydrograph, will write down 240 meter cube per second. Rainfall excess means effective rainfall 80 mm. Base flow 40 meter cube per second. Okay. Rainfall excess is 80 mm. Base flow 40 meter cube per second. What is the information given now? So you take here base flow. Peak of flood hydrograph minus base flow. What it provides? Tell me. Peak of flood hydrograph minus base flow. You are subtracting. What you will get? Peak of flood hydrograph minus base flow. What you will get? Tell me. Peak of direct runoff hydrograph. QDRH. Peak of QDRH. Subtract base flow. So that you will get a peak of DRH. QDRH is 200 meter cube per second. What is the question? Do you need peak of direct runoff hydrograph or do you need a unit hydrograph? Question is given. Peak of 4-hour unit hydrograph required. Peak of 4-hour unit hydrograph required. And the effective rainfall 80 mm. Effective rainfall 80 mm. I can take it. 8 centimeter. We'll take it 8 centimeter. No? So what is the peak of unit hydrograph? Peak of unit hydrograph is equal to peak of direct runoff hydrograph 200 divided by 8. Shall I take it? Peak of unit hydrograph is equal to, shall we take it? Peak of unit hydrograph is equal to peak of direct runoff hydrograph divided by effective rainfall depth. 200 by 8. Shall we take it or not? Shall we take it or not? Tell me. Yes, no? DRH is 200. Effective rainfall is 8. Peak of unit hydrograph, I can say 25 meter cube per second. 25 meter cube per second. Option B. Simple. First, FH and base flow given. FH minus base flow gives DRH. DRH by effective rainfall, UH. Simple direct model. FH to DRH. Yesterday session I have given clearly. FH to DRH minus base flow. DRH to UH divided by effective rainfall. Clear? FH minus base flow, DRH. DRH by effective rainfall, unit hydrograph. You will get the answer, 25. If the peak of 3-hour unit hydrograph is, peak of 3-hour unit hydrograph is 1000 cubic. Write down. QUH is equal to 1000 meter cube per second. QUH is equal to 1000 meter cube per second. The flood hydrograph peak for the net rainfall of 150 mm, base flow of 200 cubics. What is QFH? So how can I write down QFH? What is formula for QFH? Tell me. QFH is equal to QDRH plus base flow. QFH is equal to QDRH plus base flow. What is QDRH? QDRH is equal to QUH into effective rainfall in centimeter. That is QDRH. No? Direct runoff hydrograph discharge is equal to unit hydrograph discharge into effective rainfall in centimeter plus base flow. Effective rainfall 150 mm. How can I take? 15 centimeter. Effective rainfall 150 mm. I can take it 15 centimeter. No? Now, QUH 1000 cubic, 1000 into 15 effective rainfall depth in centimeter. 15 plus base flow 200 cubic plus base flow 200 cubic. What is the answer? 15,200 cubic meter cube per second. Answer is option C. 15,200 cubic. 15,200 meter cube per second. Answer is option C. Na? We can go ahead. Na? Simple. QFH is equal to QDRH base flow. We are adding. Finally we get 15,200 meter cube per second. Drainage density is the, tell me, drainage density we have written clearly. Stream discharge per unit area, no, it is not at all related to discharge. Annual runoff per unit drainage area, yearly, no, not at all related to year. No? Number of streams per unit drainage area, what is this? Number of streams per unit drainage area is stream density. It is not a drainage density. No? Number of streams per unit drainage area, stream density. It is not a drainage density. Average length of the stream per unit drainage area within the basin. Very good. So we have taken this one on L by A. Drainage density DD. Drainage density is equal to length of the stream by basin area. Length of the stream by basin area. So option D, drainage density. A unit hydrograph has, tell me, unit hydrograph has 1 unit of peak discharge, 1 unit of direct runoff, 1 unit of rainfall duration, 1 unit of time base of direct runoff. So unit hydrograph. What is the word unit represent? 1 centimeter depth. Whose depth here? Whose depth? Unit of 1 centimeter depth. Whose depth? Effective rainfall depth. It is the other name for effective rainfall. Unit is 1 centimeter depth of effective rainfall. So what is other name for effective rainfall? Other name for effective rainfall is DRO, direct runoff. Other name for unit hydrograph. Other name for unit depth 1 centimeter effective rainfall, DRO, direct runoff. 1 unit of. You can take it now. 1 unit of direct runoff. We'll consider it. 4-hour unit hydrograph of a drainage basin. A 4-hour unit hydrograph of a drainage basin is triangular in form. Okay, triangular in form. We'll draw the diagram. 4-hour unit hydrograph, triangular form we are plotting. Discharge meter cube per second. Time base in hours we'll consider. 50 meter cube per second. This is 50. Time base of 15 hours. Time base of 15 hours. It is the area of catchment. Drainage basin area. Half. Triangular half into time base 15 hours into peak discharge 50 meter cube per second. To convert hours to second, 16 to 60. This is equal to area of catchment into unit depth 1 centimeter. 1 centimeter considered as, tell me, 1 centimeter considered as 10 power minus 2 meter. Half into time base into peak discharge. Half into time base 15 hours. 50 meter cube per second peak discharge into 60 into 60 for unit conversion. Area and 10 power minus 2 meter effective rainfall. 1 centimeter effective rainfall. What is area you are getting? Tell me. Calculate it. Solve for area. What is the area you are getting? 135 into 10 power 6 meter square. 135 into 10 power 6 meter square. What we can take it? 135 kilometer square. 135 into 10 power 6 meter square. We'll consider it as 135 kilometer square. So what is the answer? Option B. Option B is the answer. 4-hour unit hydrograph. Area 135 kilometer square. The upper limit on the area of the basin for the applicability of unit hydrograph is taken to be. So unit hydrograph is applicable up to, clearly I have mentioned in the previous session, applicable up to area of 5000 kilometer square, not more than that now. It is applicable up to area of 5000 kilometer square. So before going to close the session, guys, I would like to tell you one thing. Unacademy is providing you live interactive classes with limited strength for each and every of your doubt. Very important. Listen carefully. Each and every doubt of yourself, you put a message in the comment box of Unacademy window while class is going on, not after the class. While class is going on, your doubt will be cleared immediately by the faculty. the top online education system in India is Unacademy. The platform is having best app for live interactive classes. No coaching center is having this much best app for live interactive classes. So remember, Unacademy is providing interactive sessions for GATE and ESE at best price in the market. 6 months subscription 18,000 rupees. 1 year subscription 22,500 rupees. 6 months 18,000, 1 year 22,500. Along with that, if you use my code Engineering Guru, remember code. What is the code? What is the code? Engineering Guru or else KP Civil. If you use the code Engineering Guru or KP Civil, you will get a free study material, free online test series. Unacademy provide you one test series. Myself will give you one more test series. So, free study material, free online test series, and watch the video for unlimited. We are not putting any restriction here. Other coaching centers will put restriction regarding how many times. 1 time you can watch, 2 times you can watch. No, here there is no such kind of restriction. So best platform for GATE and ESE online classes, live interactive classes, that is Unacademy only. Remember, we are not teaching in Zoom. We have our own app to teach GATE and ESE online classes. Zoom, Google Classroom we are not using. Unacademy app has a design with its own classroom tools. Best in the industry. Okay? And we are having best faculty, top faculty from coaching centers. Myself, with 16 years of teaching experience, trained 150 plus batches for GATE and ESE. And then RP sir, the 10 years of GATE and ESE teaching experience, trained more than 100 batches. And Rafi sir, Abdul Rafi sir, who is also having 16 years of teaching experience, trained more than 150 batches. We three with you till you crack GATE and ESE. And our speciality, we simplify the subject for you. We will make it the most complicated subject very simple. So if you have any queries, you want to ask me, WhatsApp 8985933112. We are with you till you crack GATE and ESE. Take plus subscription in Unacademy using my code KP Civil. You will get various benefits related to it. Okay? I am with you, our faculty team with you till you crack GATE and ESE. Then why to wait? Join plus subscription in Unacademy using KP Civil code. Let's crack it.